In example 5, if you were to plug in infinity, you would get infinity squared, which is infinity, plus 1, which is infinity. Square root of infinity would still be positive infinity, so we're getting positive infinity minus infinity. Now, you might think this equals 0, but that is actually an indeterminate form. We can't determine what infinity minus infinity is. We don't know if is this infinity larger than that one? Is this infinity larger than that one? Are they equal? We have no idea. So this is not something we can use. Instead, we're going to have to create a fraction out of this. So you're going to put a 1 on the bottom. And we're going to multiply by the conjugate. So the whole goal here is to find a way to create some fractions so that we can use our theorem that says when you divide by infinity, you get 0. So instead of infinity minus infinity, I want some division. So we're going to multiply by the conjugate and see if that helps us create some fractions. Multiplying by the conjugate, you're going to FOIL, so the radical will cancel. The outside and the inside will cancel, and then last times last, you'll have negative x squared. 1 times the conjugate is just the conjugate. You want to reduce on top. Notice how my limit is staying the whole time. The limit stays with the problem until you actually plug in your infinity. That's true of every limit problem. The limit stays on the problem until you actually plug in the number. Now, if I were to plug in infinity, let's see what happens, see if I can get an answer out of this. So we have 1 over infinity squared will be infinity, plus 1 is a bigger infinity. Take the square root of that, we have infinity, plus another infinity. Infinity plus infinity is a larger infinity, and 1 divided by infinity is 0. So the answer in this problem is 0. In example 9, we are evaluating this limit at infinity. If you plug in infinity, you have infinity minus infinity again. So that's not something you can actually determine. We need to do a little bit of algebra to make this something we can actually plug infinity in and have an answer to. So in this problem, you want to try and factor out an x. So we are going to keep the limit in front, factor out an x, and see if this helps. So if we plug in infinity, we're going to have infinity times infinity minus 1. Now 1 is such a small number that subtracting it from infinity isn't going to change the fact that it's infinity. So you just have infinity times infinity, which is a bigger infinity, so the answer is infinity. Example 10. If you plug in infinity here, you'll have infinity squared plus infinity, which is infinity. Then on the bottom, you'll have 3 minus infinity, which would be negative infinity. But this is another issue where you can't have infinity divided by infinity. We don't know if they're the same and that equals 1. We don't know if one's larger than the other, and you could get infinity if the top is larger, or you could get 0 if the bottom is larger. So this is an indeterminate form, and we got to do something different than just plugging infinity in. So what we'll try is the technique where you divide by the largest variable in the bottom. So that in this case is an x, so we're going to multiply by 1 over x on top and on bottom. So that is going to give me x squared over x plus x over x over 3 over x minus x over x. Reduce this. So that's going to be x plus 1 over 3 over x minus 1. And now try plugging in infinity again. So that'll be infinity plus 1 is a bigger infinity. 3 divided by infinity is 0. So that'd be infinity divided by negative 1, which would be negative infinity. And that is the answer. Example 11. Sketch the graph of the polynomial by finding its intercepts and its limits as x approaches infinity and negative infinity. Well, they're telling you what to do in the directions. They don't always tell you what to do. Usually they'll just say sketch the graph. Now we talked about this in pre-calculus, but let's just kind of review what we are doing here. This is in factored form, which is really nice because you are able to set each factor equal to 0, and that will tell you where it's crossing the x-axis. If we want to know the y-intercept where it's crossing the y-axis, you can plug 0 in for all the x's and multiply the remaining numbers together to find what the y value would be. So that tells you where it crosses the x. That also tells you where it crosses the y. If you remember pre-calculus, we also can check the multiplicity of the factor to figure out whether it's going to touch the intercept or cross the intercept. And then when they add these limits at infinity, this is telling you what happens on the far left side of the graph. So is the arrow going up or down? And this tells you what's happening on the far right of the graph. Is the arrow going up or down on the right? Now this, in pre-cal, we were able to determine without limits because we found the degree of the entire polynomial and we decided whether it was even and it went up like a parabola or down like a parabola, or we looked at the degree and decided whether it was odd and it went in opposite directions, so either down up or up down, just like a cubic function. So you can use pre-calculus to graph this, but you also should now be able to use calculus to sketch this graph. So let's do it together. Let's start by finding the x-intercepts. So to do that, we set y equal to 0, which means we're going to set each of these factors equal to 0. So we get 2, we get 1, and we get positive 1. Now, this doesn't say 2, but in pre-cal we also checked the multiplicity. So this has a multiplicity of 4, so it's going to touch the x-axis. This has a multiplicity of 3, so it's going to cross the x-axis. This has a multiplicity of 1, so it's going to cross the x-axis. So these are our x-intercepts that they asked for. We're then going to find our y-intercept by plugging in 0. So that is going to give us positive 16 times 1 times negative 1. So we're going to get negative 16 for the y-intercept. Then let's find our limits at infinity. So we're going to plug in negative infinity and see what happens. Okay. Negative infinity minus 2 is negative infinity. Negative infinity plus 1 is negative infinity. Negative infinity minus 1 is negative infinity. Anything to the fourth turns positive, so this is positive infinity. Cubed will keep it negative. A 1 will keep it negative. A positive times a negative is a positive. So at negative infinity, we go to infinity. So what this tells me is, on the graph, far left, negative infinity direction for x, the y's are going up. So there's an arrow going up on the left. Now we want to figure out what goes on the right. So we find the limit as x approaches positive infinity. And we plug positive infinity in for all those x's. So we're going to have positive infinity minus 2, positive infinity plus 1, positive infinity minus 1. That would be positive infinity to the fourth, which is infinity, positive infinity plus 1, which is positive infinity, positive infinity minus 1, which is positive infinity, positive. So that means on the far right, it goes up. Now in pre-cal, what we did was we added up all the multiplicities and got 8. And so since it was a positive and the leading coefficient is positive, we knew it was going to look like a parabola and go up on each side. But now we can use calculus to prove why it's going up, up. And so if we plot our different intercepts, so -1, +1, and 2, so plot those, then we know that at -1 it crosses, so that arrow is kind of too far away. Cross through, going up. At +1 it crosses, but it also hits -16 on the y, so go down and get -16 and then cross through. Then we see that it touches at 2, and then it goes to +infinity.